How's it going, guys? Welcome to video 4 of the Arduino Basics series. In this video we're going to discuss sonar sensors. Since we already covered the basics, this video is going to be a little shorter. What is a sonar sensor? Sonar sensor is this little device you see on your screen. One side has VCC, our voltage in, the other has ground. Then we have a trig and an echo. Our trig emits a sound. It's a frequency way higher than the human ear can hear, and the echo receives that sound. How does it work? So, like echolocation, it sends a frequency/sound wave and then measures the distance of nearby objects based on how long it takes for that frequency to bounce back. And that's actually all you need to know for now. Let's get started. The supplies we'll need are one breadboard, our sonar sensor, 4 resistors. It says 5, but we'll only need 4 between 200 and 1000, our 9-volt battery adapter and our 9-volt battery, our power supply, an LED per resistor, preferably 4, and then a small handful of jumper wires. Let's go ahead and set up our breadboard like this. Make sure to leave 2 spaces right here and plug in our sonar sensors starting at 45 with ground. Then let's go ahead and launch our Arduino IDE. Start with a fresh sketch, and then we're going to declare our pins. So we're going to make our trig pin 9, we're going to make our echo pin 10, and then we're going to declare our LED as pin 13. Let's go to our setup. We have to make our trig an output, then we need to make our echo an input, and our LED an output as well. For our loop section, we're going to want to tell our sonar sensor to wait for 2 microseconds, then to send out a signal for 10 microseconds, and then next it's going to wait again. Then we need to read our echo time. So let's go ahead and create a variable for duration, and we're going to set that equal to pulse in. This is going to read how long it takes for us to receive a high echo input. Distance based on that duration we received. It's going to be 0.034 divided by 2. That's all. Next, let's make our first if statement. We want to tell the Arduino that if it detects a object within 20 centimeters to turn the LED on, but if it doesn't, let's turn the LED off. So if distance is greater than 0, and distance is less than 20, digital right, LED 0, low. Else, digital right, LED 0, high. Sorry, I meant to put low there. Let's switch that out real quick. There we go. Lastly, let's add a 500 millisecond delay. And let's go ahead and verify our sketch and compile it. Let's go ahead and add a jumper wire to our trig, our echo, and our D13 LED pin. We're going to connect that LED to D13, then our trig to D9, and our echo to D10. Next, let's plug in our Arduino and add our power supply. DC battery connected. Let's turn it on, see what happens. As you can see, when I wave my hand in front of it, it turns the LED on. As soon as my hand leaves, the LED turns off. If I remove my hand back a bit, more than 20 centimeters, the LED will turn back off. Let's go ahead and edit our code a bit. Let's change our LED to an array of LED pins. We're going to make it pin 3, pin 4, pin 5, and pin 6. Next, we need to declare how many LEDs we have. So let's name that unnum LEDs and set it equal to 4. Lastly, we have to set a threshold, how many centimeters we want. Let's do 20 centimeters, 15, 10, and 5. Let's get rid of pin mode LED 0 output, and let's replace that with this for loop you see right here. Then let's copy that and put it right in front of our if statement from earlier. Lastly, let's change this to thresholds, and let's change our LED 0 to our LED pins array. I means it's going to index, meaning it's going to call a certain number from that array. Then let's verify and upload our sketch. Then let's go ahead and plug trig into pin 9, echo into pin 10. And then we're going to plug our first LED into 3, the next into 4, the next into 5, and 6. Sorry, I'm taking my time a bit. I'm trying to hurry up. Then let's plug in our Arduino. And power on. Now let's see what happens when we come close. Whoa. As you can see, multiple LEDs are lighting up depending on how close we are. How cool. And that's all from me. I want you guys to try to add one more LED and also mess with the delay times to see what happens when you lower them or decrease them. See if it messes with your circuit, messes with efficiency, see if it makes it better. That's all for today. I hope you guys enjoyed. Bye-bye.